Hello, in this video we'll be talking about two-dimensional integer arrays. Now the thing with two-dimensional integer arrays is that they can seem a bit scary at first and a little bit confusing on how to configure them. But trust me, the more you work with them, the easier and more intuitive it will get. So the way I like to look at two-dimensional integer arrays is like an x and y graph. You have the x sort of rows, or rather columns. Sorry. We'll have 1, 2, 3, 4 on your x plane, and then the y rows are going to be going to be responsible for going from up and down. And so in order to replicate sort of this sort of pattern here, we can use the two square brackets to indicate our size. So let's do it right now. Int r, and then because right here we have 1, 2, 3, 4, 5 rows. To 5 first, and then how many columns? 1, 2, 3, 4. And we'll have, or rather, 4 columns, or rather, the length of each row. So now we want to zero initialize it. This will initialize everything to zeros. And so again, what this is gonna look like if you replace all these stars with zeros. That's what it's gonna look like. We have 5 rows, 1, 2, 3, 4, 5, and the length of each row is going to be 4. 1, 2, 3, 4. And so let's go ahead and start using some for loops to sort of go through this. So I'm going to go ahead and create some for loops right now. For int y equals 0, y under 5, and then plus y. Now I'm going to go ahead and start assigning to these variables. So right now we have a for loop that's going to go through each sort of row. So 1, 2, 3, 4, 5. But what we need to do is we need another for loop inside of this one in order to set the actual row number. So we need a inner for loop, and x equals 0. And like how I said before, this is going from up and down is the y value, and then going from left to right is our column or length. So x equals 0, x under 4 plus x. And then the way we assign to them is through r at the yth row, and then per x, we want it to be equal to x plus 1. All right. So, and then we want to print them. Let's go ahead and print them right now. I'm going to do pretty much the exact same thing. Y equals 0, y under 5 plus y, and then for int x equals 0, x under 4 plus x. And then we're going to again do the exact same thing. Print f. What did I forget here? Oh. I forgot to do this. There we go. And then in our print function, we can do print d. Let's go ahead and do a comma and space. Then r y at x. And what did I forget? Oh, yep. Column right here. That looks good, and let's go ahead and run it. All right, so as you can see here, we have a whole bunch of numbers. Let's go ahead and sort of make this a bit more neat. So in our outer for loop, after we print a row, we're going to print a new line. N, and then there we go. And then now we should see a much better view. So we can see here 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then what we can also do is in our outer for loop, we can print the row instead of just the values. So print the y value, remember, is going to contain our row. So we want to print row, and then let's go ahead and just print y. What did I forget? Oh, print f. That looks good. All right. And so what did I forget here? Did argument not use format string? Okay. I forgot to do %d. %d. There we go. And then what we can see here is the rows being printed. And then let's go ahead and actually do this so that it's still a little bit more, a little bit neater. Alright, there you go. So now we can see our row 0, row 1, row 2, row 3, row 4. And then to make it even a little bit easier to understand, we can do +1 so that we can actually start counting from 1 in our perspective. 1, 2, 3, 4, 5. And so the reason why it's only going from 1 to 2 to 3 to 4 is because because every time we're assigning stuff in here, the x value, if you remember, is being reset back to 0 because that's what we've asserted that we want to start right here. And so every time this loop finishes, this loop is going to increment by 1 plus y. And so if we wanted to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on, we would need to make a constant or variable outside of our loop that will remain constant, or that will be constantly tracked rather than constant. My bad. If we had a constant value, then it wouldn't change at all. But if we want a value that's going to continue changing every time our loop iterates, then we can do that right here. Right? X or val equals 0. We can start printing at 0. Let's start printing at 1. So r equals val. And then val plus val. So now we see a constant increasing number. Yep, and as you can see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on and so on. So the point here is that the way I visualize two-dimensional arrays is by visualizing an x and y graph. If you're math savvy, that may help you a bit more. If you're not, then just start working with them a lot more, and they'll become more intuitive. The first row, or the first sort of square bracket, is going to represent the row. So 1, 2, 3, 4, 5, and then the second one is going to represent the length. 1, 2, 3, 4. So I hope that was a bit helpful in helping you understand two-dimensional arrays.